Okay, so now we're going to do some more problems here right now. So a pair of dice are tossed. Find the probability that the sum of the two dice is 8, given that the sum is even. All right, so really what we're doing right here is, well, these are possible rolls. These are possible rolls. All right, so what we're doing right here is like 1 plus 1 is 2. So we're just filling this table in. I wanted to explain how these numbers exist. So then what if you roll a 2 and then a 1? That'd be a 3. 3 then a 1, a 4, so on and so forth. So what happens if you roll a 1 and then a 2? That'd be a 3. What happens if you roll 2 2s, a 4, so on and so forth. What happens if you roll a 1 and then a 3? Well, that sum would be 4. So this is how this table works. So basically, I just wanted you to fill this table in one time to gain understanding on how it works. Oops, like, see, I had a brain fry. I wrote 7 7. That should have been 8 9, 8 9 10, 6 7 8 9 10 11, 7 8 9 10 11 12. All right, so we filled in this table. All right, so let's be very pure math about it at first. So what's the probability that the sum of the dice is 8, given that it's even? All right, so that's going to be the probability that it's 8 and even over the probability it was just even. All right, so how many 8 and even numbers are there? 1, 2, 3, 4, 5. All right, so there's 5 8 and evens, which is really just 5 out of the 36. How many even numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Half of them. All right. So, again, just practicing the formula, how things work, being a little too tedious right now, but then booms, the 36 cancels. You don't really have to worry about that, but 5 out of 18. So, given that the number was even, our sum is even, what's the probability that we rolled an 8? Well, 5 out of 18 tries, we'll get an 8 when we have an even sum. That's what that means right there. All right. So we wrote down the formula for that one. We really don't need to write it down again because the formulas are good. It's good to know and understand them, but sometimes thinking can just simplify everything. So a pair of dice are tossed. Find the probability that the sum of the two dice is 12, given that doubles were rolled. All right, so double, 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 double. All right, double 1, double 2, double 3, so on and so forth. All right. So it's that right there. So how many doubles are there? There's 1, 2, 3, 4, 5, 6. All right, there's 6 doubles. What's out of those 6? How many summers are 12? Only 1. So when you roll doubles, you have a 1 in 6 shot of having a sum of 12. That's what that means. A pair of dice is tossed. What is the probability that doubles are rolled, given that the sum of the two dice is less than 7? All right. So it has to be less than 7. So we only care about all these numbers right here, right? How many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right. So out of the 15 sums that are less than 7, how many of them are doubles? 1, 2, 3. So 3 out of 15 or 1/5. Formula, logic, reading comprehension, all this is integral parts for conditional probability. All right, let's just knock out one more table stuff. Ooh, formatting got off a little bit. That should be there, that should be there, that number should be there, and that number should be there. Not sure why when you save a Word document as a PDF how this happens sometimes, but it does. So in this problem, shows employment status of individuals in a particular town by age group. So if a person in this town is selected at random, find the probability that the individual is employed part-time, given that he or she is between the ages of 35 and 49. All right. Part-time, given between 35 and 49. All right. So that given part's huge. So once we get that far, well, it's probably that they're employed part-time, 179, over the 864 total. And again, that's kind of meaningless to me, so let's just convert that to a decimal. So about 0.21, and then you can times it by 100 to get 21%. So what this means is 21% of adults 35 to 49 are employed part-time. All right. If a person in the town is randomly selected, what is the probability that the individual is unemployed given that he or she is over 50 years old? So now that's the given, and we want unemployed. In this one, we unemployed, 173 over the 778. About 0.22 times by 100, 22%. And if a person from town is randomly selected, what is the probability that the individual is employed full-time given that he or she is between 18 and 25 years of age? All right, 18 and 25 years of age. Given that, what is the probability that they're employed full-time? $185 over 536. 185 divided by 536. About 0.35 or about 35%. All right, and that's